Today we're going to discuss about symmetry of molecules. The term symmetry will reveals the beauty of an object. That means it gives the physical properties of the object. Here today we're going to discuss about symmetry of molecules. To know the symmetry of molecules, one should know structure of every molecule and the terms like symmetry operations, symmetry elements. Now, symmetry, what is symmetry operation? Generally, symmetry operation is a operation which we are doing on the molecule physically. That's why we are calling it as physical entity, and this symmetry operation should be with a specific condition to get the equivalent configuration. And the most important thing is should not disturbing the center of gravity. We have to operate the symmetry operations. Okay, so symmetry operations are three types. One is rotation, reflection and inversion. Rotation operation. So here we rotating the molecule with a specific condition to get the equivalent configuration from the original one. Here one have to know what is equivalent configuration. So equivalent configuration is nothing but the configuration which is having the same molecular formula, same structure, but the position of similar atoms is different. For example, here if we are taking the water molecule as example where it is having the V shape, oxygen H2O, right? So oxygen with two hydrogens, if we label the hydrogens like HA, HB, so while we rotating 180 degrees rotation, if it is water molecule, so if it is oxygen, these two are hydrogens. When I rotate 90 degrees, it will not give the equivalent configuration because the structure is different, right? So again by rotating 90 degrees, that is totally 180 degrees rotation, only I am getting the equivalent structure to the original one. That is same molecular formula and same structure to the original one, but position of atoms is different, right? So here if you see HA is here, HB is here. By rotating 180 degrees rotation, we getting the equivalent configuration like HB has rotated here, HA is rotated here, right? So HB, HA. This is equivalent configuration to the original one. The specific condition is here is 180 degrees rotation. By rotating 180 degrees only, we getting the equivalent, not 90 degrees, not etc. Right? So to get the equivalent structure, if any molecule can have its specific angle of rotation. Next, reflection. Reflection is nothing but we putting a mirror image in the molecule. So here also again I am taking the water molecule as example where it is having the V shape. If I put the mirror like this, what will happen? It bisect the molecule into two halves, right? So the half of the oxygen here, the half of the oxygen here. HB will reflect here. HA will reflect here. That means the right side of the HB will reflect at left side of the HA will reflect at right side. So if we see the resultant configuration here, HB will come here, HA will come here. That means the mirror image is bisecting the molecule into two halves which can be reflected to each other. Next operation is inversion. So inversion is nothing but if we pass a straight line through the center of gravity, it should reach two similar atoms at the same distance. So here from the center of gravity, if I extend the line, right? So it is reaching OB as well as OA. That means OA is inverse to OB. OB is inverse to OA. Here the OB and OA. That means in carbon dioxide, OA, OB are inverse to each other. The next term, symmetry elements. Symmetry elements are geometrical entities. These can be generated by doing the symmetry operations on the molecule. Okay. Generally, these are 5 types, and the one is rotational axis of symmetry. It can be represented with the Cn and it can be generated by doing the rotation operation. And the second symmetry is plane of symmetry. can be represented with sigma, and it can be generated by doing the reflection on the molecule. The third symmetry element is improper axis of symmetry. It can be represented with Sn and can be generated by rotation followed by reflection. Not only by rotation we getting the improper axis of symmetry here. Rotation followed by reflection only we get the improper axis of symmetry element. Next, the fourth symmetry element is inversion center of symmetry, can be represented with I, and the symmetry operation is inversion. By doing the inversion operation, we'll get the symmetry element. Next, the fifth symmetry element is identical element. This can be represented with E, and it can be generated by doing the 360 degrees rotation or doing nothing on the molecule.